My name's Steve Running, professor here at the University of Montana, and it's No, I think you're supposed to save that for our guest here. I'd like to welcome you to the Presidential Lecture Series tonight, and certainly want to start by thanking President Dennison for organizing and financing these lectures. This particular lecture is the Brennan Guth Memorial Lecture, and the Guth family is here with us tonight, and so I think we should thank them specially for this lecture. So my task now is to give a quick introduction to Dr. James Hansen. And I could go through the normal sort of chronology about him growing up in Iowa, 3 degrees at the University of Iowa. He then went off to New York to the Goddard Institute and never went back. He's been there since 1967, if I remember right. I don't want to take the time to relate his unbelievable resume to you. I recommend, if you don't believe me, that you just put his name into Google Scholar, or if that isn't good enough, put his name into Google News. You will melt your computer with the volume of information that you'll get on Jim. What I decided to do to try to put you in the frame of mind for tonight comes back to this picture. And this was the summer of 1988, and Jim Hansen went in front of a congressional committee and relayed to them that global warming was no longer just a theory, that global warming had started. And I, as a quite junior climate scientist at the time, I got to my office the next day, and I don't remember that we had email yet. And so I think it was the phone ringing off the hook, and all my friends were calling, "Did you hear what Hansen told Congress yesterday? Is he crazy?" So I think it's important for us to realize that the climate scientists in 1988 were not yet ready to state that global warming had started, except for Jim Hansen. And of course, now as we sit here in 2007 and look back the last 20 years, guess what? He was right. And so I find it very significant that I think every one of us came out here tonight because we wonder what the next 20 years will bring, and 30 years and 50 years. And I can't think of any person in climate science that I would rather hear from tonight than Jim Hansen. You'll hear from him now.
Thanks very much. And thanks to Steve and his wife for their hospitality, for the was it Moostrul beer, and I'm not going to tell my daughter, who's a vegetarian, or my daughter-in-law, who's also a vegetarian, about the elk that you shot. Also, I would like to apologize to the organizers of that little rally about no new coal, which I said I would come to, and then we kind of took too long at dinner and Steve kept me on a short leash. But in fact, I've tried to encourage that sort of thing, because I think until the public stands up, the politicians are not going to do what's necessary. So we really do need to have public display of interest in this topic. Now, and one final thing I should mention, just for the sake of accuracy, that photo actually is not 1988. There weren't that many photographers in 1988, but in 1989, when I sent there wasn't emails. I sent a fax to Al Gore when I was going to testify to his committee in 1989. 1988 was Tim Wirth's committee. And that was the one during the drought year, which got a lot of attention. But then in 1989, I sent a fax to Al Gore and said, when I testify, please ask me about this line and this line and this line, because those are not my words. Those were inserted by the White House. And he called me up at home that evening and said, is it okay if I tell the New York Times? and I knew I was going to be in trouble anyway, so I said, sure. And so there were lots of photographers, and that's where that photo came from. Yeah. Okay. Now, this is the gizmo that goes, I point it this way, this way, this way. Okay. Okay. Yeah, can you hear me when I'm away from that? Okay. Okay, there's a gap between what is understood by the relevant scientific community about global warming and what is known by the people who need to know, and that's the public and policymakers. There is, in fact, I believe, a crisis. And it's hard for people to understand that because we don't see that much happening. Global warming is much smaller than day-to-day weather fluctuations. But part of the problem is that there's more global warming already in the pipeline. The ocean is 4 kilometers deep. It takes it several decades just to give you 50% of the eventual response. And so there's about as much global warming in the pipeline as what we've already achieved. And in addition, it turns out there are positive feedbacks and negative feedbacks in the climate system, but what has become very clear only really in the last 5 years is that positive feedbacks predominate. And that gives you the combination of positive feedbacks and warming in the pipeline means that there's the danger of passing certain tipping points in the climate system where additional effects can occur with very little additional forcing, if any. So there's the danger that you can have changes that are out of your control and changes that could really produce a different planet than the one that we've been accustomed to the last several thousand years. But the other half of the story is, I think, a very positive one. If we would simply realize what the situation is and take the actions that are needed, it's in fact practical to avoid passing those tipping points. And there are other benefits of that. It had just become conventional wisdom that, oh, we're going to put 600 or 700 ppm of CO2 in the atmosphere. The ocean is going to be very acidified. You're going to not be able to, coral reefs won't be able to survive in that kind of a acidic ocean. The same pollutants or related pollutants are very damaging to human health and agriculture. But the problem is, and we're going to have to get beyond fossil fuels at some point anyhow. We're already probably close to peak oil production. So eventually we're going to have to figure out how to get energy without using fossil fuels, and it would make sense to do that sooner rather than later. And it would frankly be very beneficial to the United States to get there first. We would have technologies that we could sell to the rest of the world. The problem is there are certain special interests that are getting very good profits right now, and they don't want to lose those. So they're influencing the system enough to prevent us from moving So global warming is 0.8 of a degree Celsius, 3/4 of that in the last 30 years. We're now on almost a straight trajectory upward, although fluctuations from year to year. Much smaller than weather fluctuations from day to day, and even if you average the temperature over a month, the anomalies include negative anomalies as well as positive ones. So a given month can be colder than normal. But if you average the temperature over several years, then those weather patterns get averaged out. And you can see the nature of the global warming that's occurring. It's larger over land than it is over. This is the temperature anomaly in the first 6 years of this century relative to the base period 1951 to 1980. And the warming is larger. Yellows and reds are positive warm anomalies. It's larger over land than over ocean mainly because of the long response time of the ocean. It still hasn't responded. It's larger at high latitudes than at low latitudes because there are positive feedbacks at high latitudes. As you lose ice and snow, the surface is darker and absorbs more sunlight. It's larger in the northern hemisphere than the southern hemisphere because there's more ocean in the southern hemisphere, and around Antarctica, the ocean mixes very deeply, so it hasn't warmed very much yet at the surface. Nevertheless, an educated person can ask the question, is this just some sort of theory? And actually the nature of these comments I sort of modeled on what the NASA administrator said, not to focus on him, except he is the head of the largest science agency in the world, and it's my point is that an intelligent, well-educated person can ask this question. I get doctors and lawyers emails from them asking, and they've read Michael Crichton's book, and they hear different things, and they are not convinced. Do we really need to wrestle with global warming? And it's true, there have been large climate changes in the past. And therefore, the question is asked, well, isn't it arrogant? I mean, those climate changes in the past were not caused by humans. So why should we worry about smaller climate changes caused by humans? Well, I hope I can make that clear. This is a record of temperature in Antarctica obtained from an ice core. The ice sheets on Greenland and Antarctica are so cold that when it snows there, it does not melt. It just piles up year after year, and after it's high enough, the weight of it compresses the snow into ice, and the ice traps bubbles of air. So by drilling into the ice sheet, we can sample bubbles of air all the way back to 425,000 years ago, and actually even longer than that. But this particular one goes back 400,000 years. And you can see oops, that was not what I intended to do. I was intended to be here. This should be okay. So we live, time is running from left to right. We live in this interglacial period, a warm period, which is now more than 10,000 years long. And the climate fluctuations from these warm interglacial periods, which occurred periodically, the temperature fluctuation is like 10 degrees Celsius at the South Pole. We can also take ocean cores, and from those cores, which there are microscopic shelled animals that live in the ocean, and when they die and their shells sink to the bottom, they pile up. And you can take an ocean core and sample these shells for even millions of years. And we find that at low latitudes, the temperature from the glacial to the interglacial fluctuated by 3 or 4 degrees. On the global average, the ice ages are about 5 degrees colder than the interglacial periods. And there are big changes. There are other things that change along with these changes from glacial to interglacial times. I've graphed here, again, the temperature in Antarctica as the red curve, and the amount of CO2 in the atmosphere, which is the green curve, and the sea level, which is the blue curve. And the sea level is changing by more than 100 meters, or about 400 feet between the depth of the last ice age, 20,000 years ago, and the current interglacial period. The last 7,000 years, sea level has been quite constant, which is kind of an unusual situation. The planet has been warm enough to keep ice off of Canada and Eurasia, but cool enough to allow the ice to be stable on Greenland and Antarctica. And it's probably not a coincidence that sea level stabilized when sea level stabilized about 7,000 years ago. Shortly thereafter, the first urban societies came in to being, and all of them were located on coastal regions, except for Jericho, which was inland. But it's suggested that it's because when sea level was rising 1 or 2 meters every 100 years, the coastal zone productivity was much lower, an order of magnitude lower than it was once sea level stabilized. And so once sea level stabilized, then the productivity and the fish were available, so that was a place where you did have high protein food that could support urban societies. Now, as I mentioned, not only temperature was fluctuating with the glacial to interglacial cycles, but also the greenhouse gases, and methane as well as CO2 fluctuated with these cycles. And we can use the information that we get from the ice cores and other geologic data to get a measure of how sensitive the climate is to forcings. A climate forcing is an imposed perturbation on the planet's energy balance. So, for example, if the sun becomes 1% brighter, that's a forcing of about a little more than 2 watts per meter squared, because the Earth absorbs about 238 watts per meter squared of energy from the sun, averaged over the planet and averaged over day and night. But perturbations to the energy balance can be either from the energy coming in, or changes in the atmosphere, or changes on the surface of the planet. Well, we know the changes in the atmosphere from these samples of air, and there are more greenhouse gases during the interglacial periods, and those cause I don't have this down, okay. Those changes in greenhouse gases, they trap heat radiation going out from the planet. So when there's more of them, that's a positive forcing, which would cause a warming. The other major forcing is the changes on the surface of the planet. During the ice ages, there was large ice sheet that covered Canada and reached down into the United States, covered Seattle and parts of Montana and Minnesota and New York City. And the vegetation distributions were somewhat different, and the coastlines were somewhat different because of the sea level being about 400 feet lower. The change in the surface albedo was a forcing of about 3.5 watts per meter squared. So the total forcing of about 6.5 watts per meter squared maintained a temperature change of about 5 degrees, which implies a sensitivity of 3/4 of a degree for each watt of forcing. And we now have, that was an estimate for climate sensitivity, which happens to agree very well with what we get from global climate models. But the error bar on this is smaller, and we know that all of the physics is correctly in there because it's the real world. And that was derived from just looking at climate at two particular times, but we can now check that at all times during the last 400,000 years because we have measurements of sea level for the entire 400,000 years. And the water, which is not in the ocean, is on the land as ice sheets. So that tells us how big the ice sheets were. And the ice sheets will grow in both horizontal dimensions as well as in thickness. So the area of the ice sheets goes to like the 2/3 power, approximately, of the amount of water. And so we can calculate the climate forcing due to the change in the ice sheets for the entire period, 400,000 years. And we can calculate the climate forcing due to the greenhouse gases because we know those very well from the ice cores. And if we add up those two forcings and just multiply them times 3/4 of a degree for each watt, we get the calculated temperature, which is shown by the blue curve, and it's in good agreement with the observed temperature change. So it tells us that the climate sensitivity is independent of time over that time interval. Now, say something about the mechanisms. This is a graph that compares the greenhouse climate forcing due to all the long-lived greenhouse gases, nitrous oxide, methane, and CO2, to the temperature change in Antarctica over the same time period. And you can see that they're remarkably coincident. But if we look carefully, what we see is that the temperature changes tend to slightly precede the greenhouse gas changes by several hundred years. The greenhouse gas, which is not a surprising thing, the greenhouse gas and the ice sheet changes are feedbacks that are operating in response to the instigator of these climate changes is changes in the Earth's orbit, which I will talk a little bit about a little later. But the changes in the greenhouse gases and the area of ice sheets are operating as positive feedbacks, and in fact, the temperature changes are then practically coincident with, on these long time scales, with the forcing change. But those mechanisms, the point is that the greenhouse gas changes and the surface albedo changes are the mechanisms by which the global temperature changes, even though they're not the instigator of the changes. Now what is happening is the greenhouse gases are now, and I've changed the time scale here so you could see what's happening in the last century. And the amount of CO2 and the amount of methane are now increasing far off the ranges that have existed in the last millions of years. And of course, they're increasing because of our burning of fossil fuels. And in this case, the greenhouse gases have now become the forcing. We're increasing them first, and we know very well how the mechanism works, and we know the sensitivity of the climate system to these mechanisms. And given time, these forcings will have a predictable effect, and they're beginning to have that effect, which is only partially felt because of the time scale that it takes to respond, and because these are not the only forcings that humans are introducing. But the chief implications of these climate changes, and I will show this a little more clearly in a little bit later, but the instigator of these climate changes is changes in the Earth's orbit. But the mechanisms are the greenhouse gases and the surface albedo. the climate is very sensitive to even small forcings. The instigator of these changes is a very small forcing. And now, human-made forcings dwarf the natural forcings. Humans are now in control of the mechanisms for global climate change. And I think it helps perhaps to make this argument a little clearer to look at climate changes on longer time scales. Because the changes in the greenhouse gases on these ice age, interglacial to glacial changes, those occur because of a transfer of carbon between one surface pool and another. There's the atmosphere, the ocean, the soil, and the biosphere, all of which are carbon reservoirs. And this carbon can move between one reservoir and another. As the ocean gets warmer, carbon dioxide comes out of the ocean, just like it comes out of your Pepsi if your Pepsi gets warmer. And that's a major way in which this feedback works during the glacial to interglacial changes. But it's also possible to have carbon dioxide changes due to exchanges between the Earth and these surface reservoirs. They just occur more slowly. The way that carbon dioxide moves between the surface reservoirs and the solid Earth, the way in which it's taken out of the atmosphere is mainly by weathering. So the net product, water plus CO2 is carbonic acid, but when you have fresh rocks exposed, there will be weathering of these, and the ultimate product of that is carbonate sediments in the ocean floor, and that takes carbon dioxide out of the atmosphere and deposits it as carbonates. And that's typically 80% of the sink. The other 20% is deposition of organic material on the ocean floor, and some of that ends up as fossil fuels eventually. The return path is caused by when you have the subduction of ocean crust underneath a continent. With continental drift, you have the ocean crust going underneath a continent, and the high temperature and pressure causes a metamorphosis. Metamorphic rocks, basalt and other rocks are formed from the carbonates, and CO2 is released, which comes out from volcanoes and related phenomena like springs, seltzer in springs. But these processes, the uptake of CO2 by the solid Earth and the return to the atmosphere at any given time do not need to be balanced, depending upon how much subduction is going on and depending upon the rate of weathering, depending upon orogeny, mountain building. So it's interesting to look at, a quarter of a billion years ago, a quarter of a billion years ago, all the continents were kind of stuck together in the supercontinent Pangaea. But the continents broke up, and I like to focus on this period from the end of the Cretaceous to the present day, because by that time the continents were almost to their present latitudes. So that, and this last 65 million years is called Cenozoic Era. The brightness of the sun is increasing. The nuclear reactions, fusion, hydrogen being made into helium, the rate of energy production has been increasing. If you go back 4.5 billion years, it was 30% less than it is now. But 65 billion years ago, it was only 0.5% less than it is now. So that's just a change of 1 watt over that 65 million years. And likewise, because the continents were almost to their latitudes, then the forcing due to the different albedos of ocean and land is also very small, of the order of 1 watt over this time period. But the big change is the change in atmospheric composition, because the amount of CO2 in the atmosphere in the last glacial to interglacial cycles, it's only been 180 to 280 parts per million. But if you go back 50 million years ago, it was between 1,000 and 2,000 parts per million. So there's been more than 3 doublings of carbon dioxide, and the forcing is more than 10 watts. So the dominant change is, in fact, change in atmospheric composition. And the thing which has particularly determined that is the fact that India was still south of the equator 65 million years ago, but it was moving north at a rapid rate of about 15 centimeters per year, half a foot per year. And Eurasia was retreating at a rate of 1 or 2 centimeters per year. So it got rear-ended by India, which crashed into Eurasia about 50 million years ago. And that, and so just before 50 million years ago, in this period before that, the Tethys Ocean, which separated India from Eurasia and Africa from Eurasia, was being closed. And there was been an extensive subduction of this carbonate-rich ocean floor. And so the amount of CO2 in the atmosphere was increasing, and the planet was getting warmer. And this, by the way, this quantity graphed here is the oxygen 18 in the shells of these foraminifera, these microscopic shelled animals that fell to the ocean surface. And when there's no ice on the planet, which was true from 65 million years ago almost until 35 million years ago, there was very little ice on the planet. So at that time, the oxygen 18 is a measure of the temperature of the deep ocean, because these were benthic forams which live in the deep ocean. And the temperature of the deep ocean now is about 0 degrees. But at that time, it was much warmer, and there was no ice on the planet. But because when India crashed into Asia, it pushed up the Himalayas and the Tibetan Plateau. So you've got this huge area of very strong weathering. And that weathering then draws down the amount of CO2 in the atmosphere, and the planet cooled off until it got to a point where Antarctica started to have an ice sheet. And that happened then quite quickly because of positive feedback, albedo feedback. The Antarctica became glaciated. And probably because, although we don't understand all the ups and wiggles, but probably because of the negative feedback, when Antarctica became glaciated, then weathering stopped on Antarctica. And because the planet was getting colder, even the Alps and the Himalayas that may have had less weathering at high altitudes. But I think, and we don't entirely understand why the cooling has been fairly rapid in recent 15 million years. I think that it's because of the fact that the Andes have been rising very rapidly in the last 15 million years. In fact, there are measurements relevant to 11 million years ago to 7 million years ago, which show that the Andes was rising at a rate of 1 millimeter per year, which is 1 kilometer per million years. And that's a very fast rate of rise, and a lot of weathering is then associated with washing them down because they haven't grown that many kilometers. And the weight of the Andes has actually caused the subduction of ocean crust under South America to slow down by about 30%, so that the emissions of CO2 that you get from the subduction has decreased. And as a result, I think, although our proxy measurements of CO2 can't really confirm the changes in CO2 over this short time period, in any case, the Earth has continued to cool off over this time period. And I've blown up the last 3.5 million years here from the mid-Pliocene to the present, and the Earth has continued to cool off, and as it's continued to cool off, the size of the ice sheets has grown, and that's why the magnitude of these fluctuations has continued to increase. And then I've blown up the last several 100,000 years at the bottom. Now, and I will just point out that over this this graph actually goes over 600 million years. And the changes, and what this is the proxy measurements of carbon dioxide over that time period. And there's a very strong correlation of CO2 with the planetary temperature and with the amount of ice on the planet, which again implies a climate sensitivity consistent with what we get from the other paleo studies. And these climate changes are the climate changes I talked about before are really noise on this bigger curve. So these fluctuations from the glacial to interglacial are noise on this big curve, but the larger curve gives you another perspective on the influence of the atmospheric composition on the climate. And as you can see, it is huge. I mean, we go all the way from an ice-free planet where sea level was 70 meters higher than it is now, to one in which sea level was 130 meters lower than it is now. So in summary, the dominant forcing on these long time scales is changes in atmospheric carbon dioxide, but the rate at which that occurred is about 1/10,000th of a part per million per year. So it's true, you can say, oh, the natural world causes much bigger changes than humans. Well, that's right, but it's changing on such a time scale that it's completely insignificant in comparison to what humans are doing. We are causing changes more than 10,000 times faster than the natural ones on the geologic time scale. And the same is true on the glacial to interglacial time scale, as I showed earlier. And it also showed, by the way, that transition from no ice on the planet to having ice on Antarctica occurred at a CO2 of about 500 parts per million. And it also shows that it's reversible. So the changes that humans are making are comparable to the changes that occurred on the timescale of many millions of years, and they're much larger than the changes that have occurred on the timescale of the last several 100,000 years. And just let me say one thing more about this. If you notice this, darn it. 3 buttons is too many for a scientist. I guess that means 2 is the upper limit. But you see, these fluctuations, if you look carefully at these, they occur at remarkable regularity of every 41,000 years. Well, we understand why that is. The tilt of the Earth's spin axis to the plane of the Earth's orbit is now 23.5 degrees, but it fluctuates by plus or minus 1 degree with a periodicity of 41,000 years. And that's the dominant paleoclimate forcing causing those cycles of the ice ages. It's a very weak forcing. It's a very slight change, but it's enough when the tilt is larger, it exposes the ice to a little bit more sunlight, and 6 months later, the northern hemisphere ice is exposed to a little more sunlight. So you melt ice during one half of this 41,000 year period, and it regrows the other half. And so I think I already showed this, the implications of the Pleistocene. Humans, we understand the mechanisms by which the climate is changing, and humans are now completely in control of those mechanisms. The human-made changes are much larger than the natural ones, and they're much faster. And we can look at this now on the time scale that you're more familiar with. Look at just the last century. We know the climate forcings during this period pretty well, many of them. The greenhouse gases are causing a positive forcing that keeps increasing. Carbon dioxide is the biggest contributor, but there are several other gases. Volcanoes go off occasionally. This one is, I actually can simplify this if I could find my other thing. Yeah, this will work better. This is Pinatubo, and that was El Chichon and Mount Agung and Krakatoa. So we have these negative forcings due to volcanoes going off, and we have human-made small particles, aerosols, which also cause a negative forcing, and we don't know those as well. Their uncertainty is at least 50%. But if we take our best estimates and put these forcings into a climate model that has a 3-degree sensitivity for doubled CO2 and calculate the temperature for the last century, we get a different answer every time we run a climate model, because the climate model and the real world have chaos. And so it gives slightly different answers each time, but it's in good agreement with the observed temperature changes over that time period. And we can then have some confidence in projecting changes into the future. This is the last century, and then we go into the future either with business as usual scenario, which energy departments take as if it were a God-given fact that we're going to continue to burn more and more fossil fuels every year. And I contrast that to an alternative scenario in which we begin to slow down the emissions of carbon dioxide by about 30% by mid-century, and then stabilize composition by the end of the century. And the intention with that scenario is to keep warming less than 1 degree for reasons that I will try to make clear. All countries in the world, including the United States, agreed to this Framework Convention on Climate Change in 1992 with the objective of stabilizing greenhouse gases at a level that prevents dangerous human-made interference with climate. The problem is that we haven't defined what is dangerous. I think that important metrics are global sea level, because if an ice sheet becomes unstable, it takes thousands of years to regrow an ice sheet. So we can't afford to let the ice sheets become unstable. And the extermination of species is another thing which is irreversible on any time scale of interest to humanity. And there are also regional climate disruptions. And in a sense, Steve was telling me about some of them. One of the regional things is that we expect more intense rainfall and flood events, but on also the other end of the hydrologic cycle, more intense droughts and forest fires. And I guess you're starting to get some of the fires. But there are a number of other regional climate changes, but I particularly think these irreversible things are important. And The sea level, we see that the areas with summer melt on Greenland and West Antarctica are increasing. The summer melt goes down, it finds a low spot on the ice sheet, it doesn't run off the edge of the ice sheet, it finds a low spot, goes down to the base of the ice sheet, which is more than a mile thick, and lubricates the base of the ice sheet so that it starts to discharge these giant icebergs to the ocean more rapidly. The rate of discharge from these major glaciers has more than doubled in the last decade, and the mass of Greenland is beginning to decrease, and the same is true for West Antarctica. We have this spectacular GRACE satellite, which measures the gravity field with such a high precision that you can see the changes in the mass of the Greenland ice sheet. And of course, it grows during the winter and decreases in mass during the warm season. But overall, there's a downward trend of about 150 cubic kilometers per year, and West Antarctica is losing mass at a similar rate. Well, that's still a moderate rate, but the sea level is now rising at a rate of 3.5 centimeters per decade. That's double what it was 15 years ago, and that was double what it was a century earlier. And although the rates are still moderate, that would be more than a foot per century, but if it doubles a few more times, the problem is once disintegration of an ice sheet gets started, it can go very rapidly. The last time an ice sheet disintegrated, 14,000 years ago, sea level went up 20 meters in 400 years, which is 1 meter every 20 years. So we don't want to get that started. That's a tipping point that we don't want to pass. And we've seen a tipping point, I think we're seeing a tipping point in the Arctic where now the sea ice has started to decrease quite rapidly. And we've lost almost half of the summer sea ice compared to 25 years ago. We're in danger of losing it altogether. And if we were to go to, the last time the planet was 3 degrees Celsius warmer was the Middle Pliocene 3 million years ago, and sea level is 25 meters higher, which is 80 feet. It wouldn't happen instantly, but if we set the planet on a course to achieve 3-degree warming, it will eventually cause a very large sea level rise, which would have really unacceptable consequences. The entire state of Florida would be underwater, and the entire nation of Bangladesh, and about 300 million people in China, about 1 billion people in the world. So it's, more. The New Orleans disaster was a few 100,000 people. So if you're talking about several hundred million, it's just almost unfathomable disaster. So you really can't go there. And more than half of the largest cities in the world are on the coastline. So it's not just those few places that we've talked about, but there are cities all around the world that are on the coastlines. Now, what is the dangerous level? Well, I think that the warming needs to be kept less than 1 degree additional warming, because if we look at prior interglacial periods, there were a few that were warmer than the current interglacial period. But now, with the warming, I have here graphs for the warm pool in the Western Pacific and the Indian Ocean, because this is sort of the key region for the climate of the planet, because it determines the heat transport to high latitudes in the atmosphere and also the heat transports in the ocean to high latitudes. And this is a key point because it has the highest correlation of temperature with global temperature. We don't have really accurate global temperatures for these time scales, so we have to look at particular places, and I think these are the most important ones. And with the warming of the last several decades, we are now within less than 1 degree Celsius of the warmest interglacials. These warmest interglacials had sea levels that were a few meters higher, not 25 meters higher. I think we had better not exceed those kind of temperatures. The other irreversible thing is the impact of climate change on species. As the isotherms move poleward, we are in effect pushing off the planet those species that live at the highest latitudes, because any given species can survive within certain climatic zones. And likewise, the species that live in alpine regions. As the temperature rises, a given isotherm moves up the mountain, and we are pushing off the planet those species that can live in certain zones. What's happened in some of these so-called islands in the sky in the southwest is that now we start to get forest fires in the lower reaches of these, and they burn so hot that the forests are just not going to recover there. And we will push species off the planet. But in general, the problem is that species are interdependent, and now isotherms are moving poleward at a rate of about 50 or 60 kilometers per decade, which is about 35 miles per decade. So far it hasn't been a big problem. But now it's been continuous for 3 decades, and it's going to be continuous for a number of decades. And then, as it gets to be larger and larger, you're pushing species faster than they can migrate, and faster than some of them can migrate, and because they're interdependent, you can cause mass extinctions. And in fact, if you look at the history of the Earth, when there were global warmings of several degrees, there were mass extinctions of more than half the species on the planet. And you know, some scientists say, well, but other species come into being. But that takes hundreds of thousands, if not millions of years. And we can't even fathom 1,000 years. That's 30 generations. So if we destroy species on the planet now, we leave a much more desolate planet for our children and grandchildren. So I think this is a big issue. And you know, here's a very important fact which relates to the rally before this talk. When we put a pulse of CO2 into the atmosphere, say by burning fossil fuels, the amount that stays in the atmosphere decreases quite rapidly. About half of it is gone within 25 years. It goes mainly into the ocean. But then the rate at which the sinks take up CO2 slows down. And by 100 years, still 1/3 of what we put up there is still there. And by 1,000 years, 1/5 of it is still there. The reason is that the CO2 that goes into the ocean, in effect, is exerting a back pressure on the atmosphere, so it doesn't let any more in until that which is in the ocean goes out in sediments to the ocean floor, but that takes thousands of years. Therefore, we cannot put all of the fossil fuel in the reservoirs. The dark is the oil that has already been burned. And this is what we know is available, and then some people think there's more still to be discovered. Well, this is gas and this is coal. Oil and gas are enough to take us up to the dangerous level, if not probably somewhat beyond the dangerous level. And we cannot really prevent that. We're not going to be able to tell Russia or Saudi Arabia not to drill and sell their oil. And you can't capture it coming out the tailpipe. What we could do is decide coal we could deal with, and there are other reasons to deal with it. But if we decide, okay, we're only going to burn coal at power plants, and only at power plants that capture it and sequester it, that's 80% of the solution to solving a global warming problem. That's where, but we just have to realize that. And there are people who a lot of people who just don't realize yet that we have to do that. That's the same thing. So that's by far the most important thing that has to be done to solve the global warming problem. And that's why I say I would support any rallies that are trying to make this clear. Now, it's also important that we stretch the conventional oil and gas. So there is value in slowing down the emissions from oil and gas. You know, they're going to get in the atmosphere anyway, and whether we emit them this year or next year doesn't matter much if they're going to stay there 1,000 years anyway. But nevertheless, it's very important to use the existing supplies frugally, because if we don't, we're going to end up with a situation where we've got all kinds of needs for liquid fuels, and you're going to start squeezing it out of coal, or squeezing it out of tar shale, or tar sands, or something which is just completely unacceptable. That's the unconventional fossil fuels, and we simply cannot do that, or we produce a completely different planet. And there are some other, I think we're going to probably pass the dangerous level in any case, and we're going to have to figure out how to deal with that. And there are a couple of things that we can do to deal with that. We can reduce the other climate forcings, methane, black soot, nitrous oxide, ozone, and that will help offset some of the CO2. And we can also draw down the atmospheric CO2 by means of better agricultural and forestry practices, and by burning biofuels in power plants that capture the CO2 and sequester it. So is it, I mean, there are many people who are saying we have no choice. We're bound to pass far into this dangerous level. Well, I don't think that's true. I think that we could decide that by 2012, 5 years from now, we will have no more new coal-fired power plants unless they sequester CO2. And 10 years later, the developing countries will have a similar requirement, similar to the extra 10 years that we gave them in the case of chlorofluorocarbons. And then we're also going to have to get rid of all of the old technology coal-fired power plants and either replace them with the new technology or some other source of energy. I think that that is feasible, but policymakers don't yet understand it. If we follow business as usual, then we're going to more than double carbon dioxide. If we had that phase out that I just described, we would keep CO2 less than 450 parts per million. And I think that's technically feasible if we would start to do it. We do need to also stretch the conventional fossil fuels, the oil and gas, because we have to wean ourselves off of fossil fuels, and you can't do that instantly. We've got to continue to have energy, and so we have to I think, have a price on carbon emissions to stimulate the technologies that we need in order to replace the current fossil fuels, and that in particular stimulate energy efficiency, but also renewable energies and other energies that do not produce CO2. And there are many advantages in doing that. The jobs that would be generated are not inferior to coal mining. There may be quite good jobs. And there are ways to do that that are fair and revenue neutral. And there are various ways you can do that with cap and trade or carbon rations or carbon tax. But otherwise, what we're going to end up with is that we're so dependent on these things that we go to the extreme places, the Arctic National Wildlife Reserve, and the most deepest places in the ocean, and try to squeeze every drop of oil out of tar shale and everything else. And that is irrational behavior of an addict. And we've got to break that addiction. And the problem is that we have been really handicapped by the fact that the special interests who are getting big profits out of the current fossil fuel system are really muddying the discussion, and they have these contrarians who make it appear that we don't know for sure whether this is really true or we're just making up this story. But that's why we have to have people starting to stand up. And I think the democracy will still work, but we've got to use it. And I do think we're probably going to pass dangerous levels. So we should take advantage of the fact that some of these other forcings, methane, chlorofluorocarbons, tropospheric ozone, black soot, we could actually reduce those, and they're not insignificant in comparison to carbon dioxide. So that's important. And I think we could still, there's enough actually forcing in those non-CO2 forcings that if we would reduce them the maximum amount, I think we could still save the Arctic, in fact, because the present imbalance, planetary energy imbalance, is between 0.5 watt and 1 watt per meter squared. If we would reduce that to 0, then the forcing causing more melting would be essentially balanced. And there's that much forcing in those non-CO2 forcings. And we could also draw CO2 out of the atmosphere. If we would not, I'm not talking about corn-based ethanol, but biofuels that make sense, like natural grasses farmed with agricultural practices with, say, no-till agriculture, practices that actually increase the storage of carbon in the soils instead of plowing it and releasing carbon, and then burning the biofuels in power plants that sequester the CO2. You could actually draw down the amount of CO2 in the atmosphere. So there are things we could do on the long run. One thing, you know, people talk about adapting to climate change. I think we need to mitigate the climate change to avoid disastrous things, because if it get out of our control, we're really in trouble. But one way you could do it is if sea level were to rise 1 meter, you could say, well, I'm going to make a big lake. Well, you could do that with a lake, with a dam that's 200 meters high. You could make a lake in North America that's big enough to store 1 meter of sea level. It would displace a lot of Canadians, so I don't know if they would allow that. But if not, there's also, in Russia, if you would make this requires a taller dam, 242 meters, but that would store 1 meter of sea level. Again, there's a lot of people who live there, so they might not like it. But so, alternative scenario is feasible, and it makes sense for other reasons, but it's not being pursued. And the problem is, if we go even another decade without getting off of this business as usual, 2% per year growth in the amount of fossil fuel we're putting in the atmosphere, and get onto this path so that we get like at least 30% below by the middle of the century, and that's a global average. Not the US would have to go more than that. Unless we do that in the next several years, we will be at such a level that it's just impractical to get to that scenario. And in terms of responsibilities, the thing that counts is not current emissions. You know, we now hear China is passing us in current emissions. Well, that's not what causes the climate change. What causes the climate change is the integrated emissions over time, because the CO2 stays there for a very long time. So our responsibility is more than 3 times that of any other country. And Europe, Germany, UK, plus the rest of Europe, is responsible for more than 30%. So the developed world is responsible for most of the climate change, and will continue to be so for several decades. And the per capita emissions is 5 times in the US what it is in China. So we can't say we're not going to do anything until China agrees to stop. And it's to our advantage to really get started. And you know, there was a previous global crisis in which when we realized there might be a problem, we stopped building more chlorofluorocarbon plants when we realized they might destroy ozone. And then when the ozone hole appeared over Antarctica, we made this Montreal Protocol. The developed countries agreed to phase out CFCs very quickly and allow 10 more years for India and China, because they wanted to have refrigerators, which they didn't have and we did have. So we gave them 10 extra years, and we solved the problem. And that's sort of the strategy that we should use, I think. And in this case, I think there was a clear warning, the media did a good job, and the public responded very well, and the government, the U.S. government, exercised leadership and really drove the international agreements. In contrast to that, I think that we scientists have not made clear that we are really talking about a different planet if we don't do something. And I think that special interests have been the biggest problem because they have influenced the media and they have influenced the government. And as a result, the public has been confused and has not put this high on their agenda. And I think all of these groups deserve some of the blame, but the problem is the people who are going to pay don't have anything to do with the problem or have very little to do with the problem. So urgent actions are needed, most important one being a moratorium on new coal power plants. And we'll need to do some other things. For example, our utilities should be allowed to make more money if they help you conserve energy rather than making their profits proportional to how much energy they sell. There are a lot of things like that which would help, and our government needs to make them happen, but they're not making them happen. Except in 2 states are actually beginning to do that. But okay, so my suggestion is we have to influence the electoral process. And I think the way to do that, all the candidates are now starting to say, okay, global warming, we need to fix that. But ask them exactly what they're going to do, because most of the things they're talking about are not going to solve the problem. They're window dressing. Ask them if they're going to put a moratorium on any more coal-fired power plants. And if they won't promise that, then I wouldn't vote for them. And this is a really hard one for politicians. They're going to have to agree that they will support a fair and gradually rising price on carbon emissions. And there are ways to do that which are fair. You may need to have someone, a carbon czar, like the chairman of the Federal Reserve, who adjusts this carbon price so that it doesn't damage the economy, but which the business community realizes is going to continue to go up. And if the business community realizes that, they are the ones who can solve the problem, and there are all sorts of ways that they can do that. And so I think that I am. The only other thing is, let me just say one more thing. Although CO2 is increasing a little more rapidly than the IPCC scenarios, the other climate forcings, like methane, is actually, its growth rate has slowed down to about 0. And chlorofluorocarbons are also growing more slowly than the IPCC scenarios. So if we would just deal with the CO2 problem, which mainly means deal with coal, then I think the problem can be solved. And I think I will stop there. And the questions, if you like. Thanks.
Dr. Hansen doesn't know the Missoula political crowd very much, so he foolishly is agreeing to take questions. I would like to request that anyone with a question come to the ADA microphones, because this is being podcast, and so for the electronic audience, we want to be able to hear the questions and the answers. And with that, we'll open the floor to any questions for Dr. Hansen.
Steve, is this one working?
That one's
This one okay? Okay. Hi, Dr. Hansen. I want to thank you on behalf of everybody in the world for insisting that the U.S. Congress and administration confront the science that you and the other scientists have presented and not just sweep it under the rug.
That reminds me, did I make my caveat? I'm a government employee, but I'm speaking as a private citizen, okay?
Well, I'm hoping that you and the rest of NOAA and other people like Steve will continue to insist that they begin to think totally differently about what we formerly called fossil fuels. In fact, that they stop calling these carbon reserves fuels and that they instead redesignate them as our national climate preserves. Just as visionary leaders realized that we were not going to have an enduring resource of forest and wildlife and wilderness unless we set aside preserves. We have to stop burning up our climate preserves. It's a very stupid use of them, and instead formally designate them as climate preserves to be set aside to provide that ecological service that we have no idea how else to provide that. So, hope you'll. I think you.
That didn't sound like a question. But
well,
okay.
I think that you have the credibility necessary to get them to think in that very different way. So.
All right, thank you. I think there's a question over here.
Yeah. You know, I agreed with you in the beginning and the end, and we have a lot of problems with the oil companies and they are controlling things. My primary question is, I had some problem with how the sun didn't seem to play much of a factor in everything here, and you seem to say like it's constant. And when the sun burps, there's major things, and there's the thing that I'd like you to discuss is it appears that the ice caps on Mars are melting. I mean, and so, and also there's some evidence of moons around Jupiter. And these are mainstream scientists that say this. And so I'm curious if you could just address that.
Yeah, the sun is indeed a major factor in climate forcing on certain time scales. Now, I showed you the 600 million year thing, and on that time scale, it's important. It is, as I showed, 1 watt on a 65 million years, and it's significantly more on longer time scales, and is part of the reason that the Earth actually froze over 600 million years ago. Ice went all the way to the equator. The sun was significantly dimmer then. But, and it has a measurable effect on the time scale of the solar cycle. We've been measuring the sun very precisely since 1979, and we're now at a solar minimum. And next year, 2008, we should start out of that minimum. And the variation from the minimum to the maximum is about 1/4 of a watt per meter squared, which is not negligible in comparison to the other forcings that I showed. But so far, in the measurements since 1979, there's no significant trend. It's just up and down with the 11-year cycles. And that's not enough to have a major effect. Now, it's also possible that it has a variation on the 100-year time scale because you can store energy in the upper layers of the solar atmosphere. And there is proxy evidence, suggestions that the sun was dimmer during the Little Ice Age. There were no sunspots for a rather long period, the so-called Maunder minimum. And that is a very plausible theory for why the planet was cooler during the Little Ice Age. It's unproven because we don't have measurements. We just have the indications of the surface features on the sun were different. But on the time scale of, say, these glacial to interglacial things, well, these fluctuations of a watt, by the way, the variation for the Little Ice Age time scale, we're talking about at most 1 watt and probably no more than 1/2 watt. But that's, with the positive feedbacks on a time scale of the century time scale, that can be important. But in comparison to the anthropogenic forcings, which are very well measured, those are relatively small forcings. The stuff about the things changing in other directions on the planet, and that's, you know, these are the kind of things which the contrarians just throw out to confuse people, and there's absolutely no evidence that those things have any relationship to climate of the sun changing or anything. Of course, the ice caps on Mars are changing all the time. When I was a postdoc, you know, we sent up a first mission to Mars, and suddenly, just as we were halfway there, we think we're going to have some really great photographs, and a huge dust storm blew up, and you couldn't see anything on the planet for a long time period. There are fluctuations on winds and things going on Mars and other planets which don't have anything to do with the sun.
Okay, maybe back over here.
Thank you, Dr. Hansen, for coming to Missoula, Montana. I've been aware of your work since the late 80s because I worked with Greenpeace in the United States in the late 80s when we started a global warming campaign in 1989. I wanted to ask you, as a citizen, with obviously deep scientific knowledge in this regard, A, what do you make of the fossil fuel developments happening in Alberta with the tar and oil sands, the biggest oil development in the world, the dirtiest in the world, and the biggest industrial project the world has ever seen, and also the massive coal reserves in Wyoming and Montana? It seems to me that this area of the world is becoming quite crucial in the battle of global warming. The other thing, if you could, you mentioned that one of the reasons we're possibly not getting change is that the fossil fuel industry is making too much money. And what do you think that says about a democratic country when the fossil fuel industry is making decisions about what we do with our public resources and not the people?
Okay, so there are several points there. One reason that it's very important to have a gradually rising price on carbon emissions, it doesn't have to be much to start with. Business has to recognize that it's going to be there and it's going to increase. And one thing that will do is kill projects that are really idiotic from the standpoint of the planet. And that in particular applies to the unconventional fossil fuels, where this is a case of the drunken addict trying to squeeze the last drops of oil out of the most extreme situations like tar shale and tar sands and things. They just won't make any economic sense once you make the pollution pay for the damage it's doing to the planet. So that will automatically be solved if we once take these two steps that I mentioned, and one of them, the second one being a gradually increasing price on carbon emissions. And what you see from the fossil fuel industry now, although they put these advertisements in the New York Times and things to make it sound like they're really green, they're becoming green and things, but what you have to actually look at is their investments. And you have, ExxonMobil has huge profits. How much are they investing into the next energies that will not cause these problems? If they were willing to become energy companies rather than fossil fuel companies, they could solve the problem. But they're not yet, they don't yet feel the heat. They're not yet being pressured to do that. And until we figure out a way to put the pressure on them, they're not going to do that. And by the way, I think the most effective way to do that is via young people. And we have to make clear the generational inequity that we are, perpetrating on the next generations. And I think that some of these people will be affected by what their children and grandchildren think of them. So if we make the story clear enough, they may begin to pay some attention to this, even though their profits of their companies are so huge that that's giving them a different pressure. Let's see, the other question, I forgot part of your question.
What do you make of the fossil fuel industry making public policy for us as Americans?
Well, that's our problem. We still have a democracy and we need to make it work. Now, unfortunately, special interests have a power that was not planned by our forefathers. And some politicians talked about actually having campaign finance reform, but it hasn't happened really. And big money, some citizens have more power in Washington than others because of the influence of money on politics. And I still think there's the potential to affect the process through the democratic process, but that requires scientists to do a better job.
Back over here.
Thank you. I want to thank you, Dr. Hansen, for your very comprehensive presentation, but I would like to ask about your reaction to a couple of other proposed strategies for reducing greenhouse gas emissions. One is to rely more on nuclear energy, and the other is to encourage a shift from a meat-based diet to a plant-based diet.
Okay, start with nuclear energy. Well, nuclear power produces very little carbon dioxide, a little bit in the making of the plants, construction, but it's a very effective way to reduce CO2 emissions. Now, it has other problems associated with it, and citizens have to decide what their druthers are. In France, they've decided that they're comfortable with nuclear power, and they get almost all their electricity that way. In Germany, they've decided they're going to phase out every single nuclear power plant. And unfortunately, they don't get it with regard to coal. They're replacing some of the nuclear plants with coal, and they're just treating oil emissions and coal emissions of CO2 as if they're equal. But for the reasons I tried to explain, they're really not equal. We're never going to stop the oil. The easily available oil is going to get put into the atmosphere as CO2, but the coal doesn't need to be. And if you do put the coal up there, you can't get it back. So it's a big mistake of Germany to go down that path. I think I would, as a physicist, I'm not afraid of nuclear power. There are these concerns about somebody getting their hand, terrorists getting their hand on weapons-grade material and things. You have to guard against those kind of things. But I think that's a local decision. You can, if you decide you don't want nuclear power, you do have to choose something else. You have to allow windmills, or you have to do energy efficiency and other things. But anyway, but the question of eating lower down on the food chain, yeah, that's actually quite effective in terms of reducing CO2 emissions. You know, I mean, we're not going to convince some people not to eat. But
I don't get corn-fed elk.
Yeah, you know, I'll bet. Yeah, that's a good point. You know, the elk is not as bad as the corn-fed cattle.
Thank you, Dr. Hansen. I have wondered about methane. I understand that rice production in China is a great source of methane. Is that correct?
Well, it's one of the 4 or 5 big sources. Fossil fuel mining produces probably the largest amount. Coal mining and oil drilling. And you can capture the CO2 in the process of these fossil fuel industries, and that's one reason why methane has stopped growing, because we've begun to pay a little bit of attention to that. We need to pay a lot more attention. Rice, you can actually do the rice farming in ways that produce less and almost no methane, but there...
Is that happening in China? Are they?
Well, I think there has been some change. I'm not an expert on that. And it wasn't, I don't think, because they were trying to help the global warming problem, but it's a question of whether you grow whether you sometime during the season let the soil dry out or something. Actually, I don't understand exactly how that works, but there are other ways to reduce the other sources, like the emissions from landfills. We can design a landfill so that the methane is captured and then used as natural gas. And the new landfills need to be designed that way. And the farms, the fact that farms have become big business is actually, in this sense, is in some ways a benefit, because it becomes practical to capture the methane in these big farms. And so there is a lot that could be done with methane, and that's something that's has not received the attention it deserves, but once we realize we're passing the tipping point, I think it'll get more attention.
And then, thank you. My other question has to do with designing the future. Right now, it's a partisan design. We design in favor of big business. I think we have to stop competing among the various interests and seeing how they can mutually support one another, because nobody wants to see the economy collapse. So how can we support both big business and government and innovative practices?
Big business is actually eager for the government to start giving them some guidelines. There are many big businesses that are crying out for this, and they're disappointed that our government won't step up. I hope that changes fairly soon. And the natural way to do it is via a carbon price. And they need to know what that is and have some indication of how it would be expected to change in the future. And big business is the potential. We can cast them as the bad guys, but they're actually could be the good guys. They're the ones who it's the captains of industry which have the capability, rather than the government, to really solve the problem.
Yeah, great, thank you.
Yeah, thank you for your time tonight. One quick question. I'm just wondering about the folks in your community and your colleagues when you're talking about problems and issues and possible solutions. Is there anybody talking about the population growth rates in the country and in the world, and how the number of people on this planet play a role on carbon emissions, and what to do with our current exponential growth rates?
Well, of population. Actually, the population is not growing exponentially. I mean, it looks like it's shooting off the chart, but in the developed world, the fertility rate has actually declined to a level which in many countries is below replacement level. It does take time for that fertility rate to show up in the actual population, just because of the aging. The people are living longer. But even in developing countries, women are becoming less eager to have many children. It seems that the communication is improving around the world, and it's not to the advantage of people to have many children, I think, anymore. And it looks like there's a good chance population could peak at 8.5 or 9 million and then decline. And the issue is, and we can see forward to some more stable situation later in the century and beyond. The question is, and that in the process of going through that larger peak, which is more than the 6.5 billion that we have now, how much more are we going to stress everything on the planet, especially the other species on the planet? And E.O. Wilson calls this pressure the bottleneck. As population peaks, that's the bottleneck, which is how many species are going to make it through that bottleneck. I think we will eventually learn how to live in a sustainable way, if you're optimistic, and I'm optimistic, but we are going to go through that bottleneck because population is going to continue to go up for a while. But I think there's a very good chance it will stabilize and even go down on the longer time scale. It does depend, though, upon addressing poverty, because the places where it's not, fertility rate has not declined as much are the places with great poverty.
Maybe one more for each mic, and then we'll be done.
Thank you, first of all, for the lectures. It's fantastic. I'm just wondering, are there any estimated projections? I know it's quite hard to do this, but with the increasing popularity of recycling and geothermal energy and, geothermal heating, wind farms, solar farms, and other sort of green methods of conserving fossil fuels. I mean, I didn't see any projections in these figures. I guess my question is it likely that these will have an effect to offset the coal emissions?
The implication of your question is that these renewable things are still small, and that implication is correct. And they're only going to become large if we have a carbon price. We can encourage them and give them tax incentives and things, and that helps a bit. But the thing which is going to cause the tipping point and things to really take over, and it should just be natural. When most places in the country, geothermal makes sense for new buildings to take advantage of just the temperature profile in the ground to reduce your heating costs in the winter and to reduce your cooling costs in the summer. And there are ways, retrofitting a house is kind of expensive, but if you do that from the beginning, it's not expensive, and it makes sense. And it makes a great deal of sense if there's a carbon price. And likewise, the other renewables, they will do very well and will hit a tipping point, and they will become big deals. And efficiency will become much more effective with the carbon price. But until politicians understand that and have the courage to say that to the people, that's what they don't want to say. It sounds like a tax, and they feel their next election is dependent on them saying no tax. And you don't even have to have it can be a dollar neutral tax where you reduce some other tax, but you've got to put a price on the emissions, or you're not going to drive the efficiency and the renewables to the degree that's needed.
Thank you.
Last question.
Okay, well, you've said that, in your opinion, 80% of the solution is carbon capture and sequestration.
Okay, just let me clarify that, because I always say that and I don't quite mean that. What I mean is that coal figuring out how to deal with coal is 80% of the solution, and you have to give them the opportunity to fix coal and have truly clean coal, which means no mercury going into the ocean, no sulfates, and no CO2 into the atmosphere. So that's why I say carbon capture. If they really make it clean coal, then let them compete with the other forms of energy, but it is going to make coal more expensive. And my gut feeling is it's going to mean a lot of coal just ends up staying in the ground.
I also think it's a pragmatic solution. I was just wondering how that compares with the stabilization wedges that I think it's Pakala and Sakalau. Yeah, I can't pronounce their names, but how does your solutions compare to theirs?
They were just trying to point out, their paper was a nice paper, Pakala and Sakalau, if that's pronounced right. They're pointing out that there's not one solution to this. We're going to have to do a number of different things. And they made each wedge as if it was equal. Well, it's the economics that's going to determine that. And there are probably some wedges, maybe some that they said they got tired after about 7 wedges, so they didn't make any more. But there surely are more wedges, and some of them are going to turn out to be a lot bigger than others. But it's really the economics that will determine which ones are biggest. But it's not likely that there's any silver bullet single silver bullet that's going to solve the problem. It's going to take a number of different things.
All right. Let's give him a... Thank you all for coming tonight.